differences between saturated and unsaturated hydrocarbons. Differences between saturated and unsaturated hydrocarbons. So let me do something like this. Let me call it saturated hydrocarbon, unsaturated hydrocarbon, saturated and unsaturated hydrocarbon. One, it contains the required number of hydrogen atoms per molecule. It does not contain the required number of hydrogen atoms per molecule. That is number one. Number two, it undergoes substitution reaction. It undergoes addition reaction. Three, it is characterized by single bond. It is characterized by double or triple bonds. Take note of that. So we have four, though we have not gotten to that, but let me add it. This one, it has no effect on bromine water. This is known as bromine water, bromine gas, and acidified KMNO4, potassium tetraoxomanganese 7. But this one, it decolorizes. Bromine water, BROH, we call it bromine water, bromine gas, BR2, and acidified potassium tetraoxomanganese 7 solution. So these are the differences between saturated hydrocarbon and unsaturated hydrocarbon. Chemical tests. To distinguish between saturated and unsaturated hydrocarbons. Hydrocarbons. What are the chemical tests to distinguish? So the reagents that are commonly used, the chemicals are, we have A or 1. A, we have bromine gas, Br2. You know the color? Reddish brown. Take note of that. We have 2. We have bromine water, call it BROH. This one is a brown or yellow. C, we talk of acidified KMNO4 solution. You know this one is purple. These are the reagents we use to distinguish between saturated and unsaturated hydrocarbons chemically. So the point is, the saturated hydrocarbons do not decolorize the aforementioned reagents. Meaning all these reagents above, they do not decolorize. They have no effect. Why unsaturated hydrocarbons do decolorize the reagents mentioned above. Like if you turn this from bromine gas from reddish brown to colorless, bromine water from brown or yellow to colorless, acidified KMNO solution from purple to colorless. That is, you can see when we say saturated hydrocarbon, you know example of saturated alkane. This unsaturated alkane and alkyne. Meaning if you want to distinguish between methane now, it is saturated. Then either they choose ethane or ethyne. Either of the two, they are the two. Either of the two is unsaturated. So between methane and ethane now, you use this, or between methane and ethyne, you use it. But between ethane and ethyne, you cannot use it because the two are unsaturated. So if you want to use this test, it must be between alkane, remember, and alkane, or alkane and alkyne. That's all. But between alkane and alkyne, the two are unsaturated. You cannot use this. So it's between alkane and alkane, alkane and alkyne. If they can just take a member, methane, how will this swim between? Please take note of that. Number 1, unsaturated hydrocarbons. Hydrocarbon. We talk of alkanes and alkynes. Take note of that. Either of the two. Decolorize bromine gas, Br2 gas, from reddish brown to colorless. That's what they are saying. From reddish brown to colorless. So let's see the equation. Number one, let me see C2H4. This is ethane. Now reacting with bromine gas. That is addition reaction. So it will be C2H4Br, Br2. Just add straightforward. When you name this, it will be 1, 2. If you name it 1, 2 dibromoethane. That 1, 2 dibromoethane, which is written as 1, 2. You have hydrogen here, you have hydrogen here, you have hydrogen here, you have hydrogen here. So we have one bromine, another bromine here. So that's why 1, 2 dibromoethane. So the color here is reddish brown. Why the color here is a color? This is colorless. Take note of that. That's what we are saying. So if you don't use that and use ethane, C2H2, that is ethane plus bromine. You know this one will be require 4 atoms. We have done that. 4 atoms will become C2H2, then Br4, because we have 4 atoms of bromine. If you arrange this, hydrogen here, you have hydrogen here, you have bromine here, you have bromine here, you have bromine here, you have bromine here. You can see 1, 1, 1, 1, 2, 2, tetrabromoethane, which is colorless. Why colorless? And this is a reddish brown. So that is what we are saying. So 2, unsaturated hydrocarbons. Unsaturated hydrocarbons. Unsaturated hydrocarbons also decolorize bromine water from yellow or brown to colorless. You form the equation you have. Let me start with ethane. C2H4, that is ethane, plus BROH. It forms C2H4BROH. So this one is a yellow or brown. This will be colorless. It's colorless. It's colorless. It's written as this. Hydrogen here, hydrogen here, hydrogen here, hydrogen here. This is BR, this is OH. So this is C2H4BROH. The one we call it is colorless. If you want to name this, or on carbon 1, bromine on carbon 2. So it will be 2-bromoethanol or ethanol. 2-bromoethanol or ethanol. That's the name. So let's consider C2A2, that is ethyne. You are adding bromine water. That is brown or yellow. Form this. It will decolorize it. You have to put 2 here because it requires 4 atoms. We have done that. So it will be 1, 2, hydrogen here, hydrogen here. So you have Br, you have Br, you have OH, you have another OH. You can see the name. This is a 1,2 dibromo or ethan 1,2 diol, 1,2 diol, 1,2 dibromo 1,2 ethan 1,2 diol. We have done limit. That's the name. And this color will be this one is colorless. Take note of that. Let's see number 3. Unsaturated equation. Hydrocarbons. Decolorize, acidified KMnO4 solution from purple to colorless. Take note of that. From purple to colorless. So let's see the first one. C2H4. This is a 10. You are now reacting it with KMnO4. It's written as it is, how to represent it. Then with water. This one represents oxidizing agent, which is a KMnO4. That's how to represent it. Can you see that? Oxidizing agent. So this one will form, remember, structurally it's like this. Hydrogen here, hydrogen here, hydrogen here, hydrogen here. So this one will now become H, C, C. You have H here, you have H here, you have H here. So this water and O will be, it's water, then you have O to be HO, another HO, meaning OH, making 2 hydrogen atom and 2 atoms of hydrogen. So OH. So you put one OH here, you put another OH here. And this is the formula for glycol. So the formula is ethan 1,2 diol, known as glycol. So how do we form glycol? Glycol is obtained when ethane is oxidized by acidified KMnO4 solution. Please take note of that. The reaction between ethane and acidified KMnO4 will yield ethane or ethan 1,2 diol, known as glycol. And glycol, as I have told you, is an antifreeze. It is an antifreeze used in cold region to prevent knocking off engines. We have mentioned it. You see it in your past question. So glycol X or ethan 1,2 diol is an antifreeze used in cold region. It's a petrol additive added to petrol to prevent knocking of the engine. so that it will not freeze and the engine will not lock. That is exactly what we call glycol. Let's consider C2H2, that is ethyl, reacting with the same thing. So this one is represented with 4 hydrogen oxygen atoms. This is how to represent KMnO4 when it's reacting with this one represents oxidizing agent. That is a KMnO4 for oxygen. So it's added here to yield. So let's see. This structurally is like this: hydrogen here, hydrogen here. So let's put it here and see what will happen. We have 4 oxygen. So I'll say C. We have hydrogen here before, so I can say oxygen, making 2 oxygen, and we are looking for 4. So another one here, another one good. Before we now consider the remaining 2 hydrogen. So this one will be hydrogen, this also will be hydrogen. Thank God we have done this. This belongs to alkanoid, and this is a dicarboxylic acid. Oil on carbon 1, another oil on carbon 2. So it will be 1,2-dioic acid. So F. So F12, eta-12, or H12-dioic acid. Call it dicarboxylic acid, known as oxalic acid. It's known as oxalic acid, used in the preparation of carbon 2 oxide under carbon compound. We call it oxalic acid. So how do we obtain oxalic acid, or name the product from when ethyl react with acidified KMnO4 solution, where ethyl react with acidified KMnO4 solution? So it will form oxalic acid. But when ethane react with acidified KMnO4, it will form glycol. It will form glycol. Ethane will form glycol with KMnO4, while ethane will form oxalic acid. Please don't forget. So that is chemical test to distinguish between saturated and unsaturated hydrocarbons. This is the end of classification of hydrocarbons. We have seen classification based on the type of reaction, substitution reaction, addition reaction. We can use that to classify hydrocarbons. 2, as per structure, we have straight chain, branch chain, that is in chain form, and ring form, which we have aliphatic and cyclic hydrocarbons. So we look at the number of hydrogen atoms. Is it complete? Does it contain the required number of hydrogen atoms or not? If it contains the required number of hydrogen atoms, then they are saturated hydrocarbons. If it does not, they are unsaturated hydrocarbons. They are unsaturated hydrocarbons.